Today we will try to explore the 8085 emulator. Now, this will help you in trying to write your own 8085 programs as well as executing them and understand how the transfers between the registers or the memory takes place. Along with that, it will also be helpful in doing your practical exams. I believe that you people would have got the mail regarding your practical exams, which will be conducted online by means of emulator and certain questions related to your 8086 microprocessor. So let's begin with 8085 emulator. So here we are having the 8085 simulator, also called as 8085 emulator. Now why is it called so? Because it mimics or it emulates the functionality of your 8085 microprocessor even though you are using some other microprocessor in your own system. This software is developed by a person Jubin Mitra and it is available for free. I'll be sharing the download links in the description of this video. Apart from that, I have also mailed you this software a few months back so you can even download from there. Now let us understand what are the various features offered by this software. On the right hand side, what you can observe, the various registers are listed, that is accumulator, register B, C, D, E, H and L, along with the memory pointer. Now this is the memory pointer. It contains the data which is pointed by your HL register pair. HL register pair will be the address and the data which will be pointed by that address that will be stored in this memory pointer. And this side from 0 to 7, whatever be the value which you are seeing here, that will be appearing in the binary format. So this display is for that purpose. Thereafter we are having a flag register. Again it will be a 2-digit value, so 8 bits in binary and 2 digit in hexadecimal. So sign 0, don't care, auxiliary carry, parity and carry. So these are the various flag bits which we are having. After that we can see the special purpose register, that is your stack pointer, your memory pointer. Now HL is mentioned here, so that means it contains the values which are present in H and L. So that will be the memory pointer value, and the value which is stored at that pointer, that will be pointed here. Okay, so we'll see the some examples related to it. After that we are having the program status word. Now program status word is the combination of the content in the accumulator and the flag register. And then we are having the program counter. Program counter points to the address of the next instruction, so that address is stored here. Clock cycle counter, so these are not registers but it just gives you a count of how many clock cycles have happened, and then instruction counter, the same thing, how many instructions have been executed. Apart from that we are having some other instructions for your sim and rim. These are for your interrupts, so serial output data, serial input data and the various interrupts. The general purpose interrupt INTR, then the trap which is also called as RST 4.5 and is a non-mask mode interrupt, RST 7.5, 6.5 and 5.5. So these are the ones which you'll be not using right now, but and it is not also there in your syllabus, sim and rim. We have 8086 interrupts in your syllabus, so let us not look into here. Apart from that, you are having a handy converter tool which you can make use of to convert hexadecimal to decimal and binary, and if you feed in the values at any of the fields, it will provide an appropriate conversion to your hexadecimal and binary. So this is one display here on the right hand side. Now if you switch tabs from registers to, if you go to memory, this is the memory address range. Now 8085 has 16-bit address range, so the memory range is from 0000H to FFFH. So once you write the program, your memory addresses will be displayed here. If you see here, we are having the three options. So the entire memory content. So if I click here, the entire memory content is available here. 0000 has 00 value, and so on. You can find what are the values stored here. If you click on this link, show only loaded memory locations. So only those locations which are getting used by the program, that will be displayed here. So this is a much more better option as compared to the other two. And store directly to specified memory location. So if you click this, then only specific memory locations will be shown here, in which the user is going to write or read the data. Otherwise, the program memory locations will not be stored. So we'll be seeing all this functionality in a short while. Let me first explain you the various functionality of the software. Then moving to the next tab, here are the devices. This is written as IO port editor. That means it can also mimic as an input output device port address. For your input output device, the port address is of 8-bit in size, therefore only 2 digits will be there. You are having 00, so if I want to go to 01, I can make use of this tab. And if I want to send a data, or if I want to make a data as an input device, and I want to make that data available on the input device as 62 and the input device port address is 94. So I'll come to 90, then I'll move to 4 and I'll place here the required data. Suppose that is 62H, so 62 will be loaded here. And once you load the value, it will change its color, signifying that a value has already been loaded here. So here you can mimic all your input output functions. So this is one of the feature of your IO port editor. Now let us move to your left hand side display. Here we are having an assembler where you will be writing your assembly language code. This autocorrect functionality is used to correct if you have made some error in the program and it can be easily corrected by the program, then it can be done. So this is not for handling the major errors, but minor errors can be corrected. For example, instead of writing MVI A,20H, you have written MOV A,20H, so that can be corrected. But other major flaws related to algorithm or typos, that is a bit difficult for correction. And this assemble is like run. So once you have written the code and you assemble it, it will run the code. So first let me type a simple program and then we'll be looking for some specific programs like doing a 16-bit number complement and Fibonacci series and etc. So I'll show you the programs you can execute at your own end. Now let me write an program. Suppose I'll start with MBI A,20H. Then I store the content of your accumulator in the memory 5060H, and thereafter I try to load it back. So what I will do is I will first point it by means of a memory pointer. So I will load MBI H, 50H. The font of the software is quite small. You can increase the scaling of your display. I have done that to bring it to this size, otherwise it will be a bit small. If you can easily see it, then it's fine. Otherwise, if you are having difficulty in reading the text, you can increase the display scaling. So move MBI H, 50H we have done. Then next instruction is MBI L, 60H. After that, once we load it back to the accumulator LDA 5060H, so we are loading 20 again back to the accumulator. See, this program will not make much sense. I'm just executing this program to show you the functionality of the registers. After that, we will be doing some programs which will have some specific purpose. Thereafter, what we try to do is we try to perform an AND operation with 35H, or let me write here as ANI 35H. So now let us execute this program. For executing it, I have to click on assemble. So when I assemble it, the software will automatically assign the addresses, and by default it will start from 0000H. And this instruction, if we go to the editor, we see that MEI A,20H is a 2-byte instruction. You can comment it. So I can write here. So I've commented the whole code for you. Now let us click the assemble button. Once you click on the assemble button, the software will show the byte size of each instruction. So MBI A,20H is 2 byte in size, therefore 2 consecutive memory locations are allotted. So 0000H and 001H. STA 5060, so it is 3 bytes. So this will also be helpful for understanding the byte size of an instruction. Likewise, MBI H, 50H is a 2 byte instruction, so it takes 2 consecutive memory locations and so on. Apart from that, it will also tell you the machine cycles. So the machine cycles is present here. We have already discussed many of the machine cycles in the previous video, so you can refer that. Along with that, it will also show you the T states. So the MBI 20H takes 7 T states, STA 5060 takes 13 T states, and so on. Now the beauty of this program is that apart from giving the data in the numeric format, it will also help you in generating the timing diagram, and that is why I am not going to explain the timing diagram in detail with reference to your previous video. As I said, I'll just give you an overview. So how to find a timing diagram of any instruction. Now once you have written here MBI A,20H, this is the T states which is provided. So you select this T states, that is, again I'm showing that 7 is given here. If you click on this, it will give you the entire timing diagram. So if I maximize this, you will be seeing the entire timing diagram, and you can very well verify what you have obtained and how the actual timing diagram will look like. I'll just explain it here. MBI A,20H. So the 2 machine cycles will be needed. One is opcode fetch and another is memory read. So here you are having opcode fetch cycle, then you are having a memory read cycle. Opcode fetch will take 4 T states, so 4 T states followed by 3 T states, and then you can draw your address lines. that is higher order address lines, lower order address lines, followed by your ALE signals. So this three will be in sequence. After that, you can use your IO/M bar, S1, S0, read bar and write bar, and accordingly the signals will be generated. You have to, when you are drawing the timing diagram, you have to generate the signals depending upon whether it is IO read or memory read, and what will be the corresponding status signals related to that. So you can refer the timing diagram from this software also. If you are having any doubts, you can do the needful. Now moving back, let me close this window. So this is how your T states will be generated. Now here we are having a value start from. This is basically your program counter value. Here it is written 0000H. Now this point also the data is stored as 0000H, so we need not to change this value. We are having two options, run all at a time or step by step. So if you click on this button, it will start from the first and it will finish the execution of the program till the end. But we don't want that. What we'll do is we'll go step by step so that you can see the program flow. Let me click on the first step. So the first step, that means your program counter is set to 0000H. So you can see here 0000H. The program counter value states the address of the next instruction to be fetched or to be executed. So now once you click on the next button again, that is forward, so the first instruction will get executed, that is MVI A, 20H. So you see here the accumulator content is 20. Moving to the next instruction, STA5060. So here the content which is there in your accumulator gets stored in your 5060. So let us go to the memory tab and see whether we are getting the required values or not. So if you see here, 5060 is having 20H as the value. What about the remaining memory location? So the remaining memory location is having a hex code as a value, which is nothing but your program. So your program is taking a space from 00 to 000D, and it is getting converted to hex code format. So MBIA has an equivalent hex code of 3E, 20 gets stored as such, STA has an equivalent hex code of 32, and 5060 is stored here. The lower byte gets stored first, higher byte gets stored then, and so on. So that is what you are observing here. Now coming back to the register tab, next instruction is MBI H, 50. Then your H is having 50H. Then if you see your memory pointer is showing 5000H, because till now we have not loaded the value of L. So let me go to the next pointer. L also got 60, so memory pointer is 5060. Also we can notice here the memory element, which is the content of the memory pointer. So content of the memory pointer is 5060 is pointing to the address, and the content at that address is 20, so that is what is stored here, 20. Then we again load it back to 5060, so nothing much change will happen. So if I go here forward, so accumulator will be 20 because that is the data which is stored there. Thereafter we will be performing an AND operation with 35. Now if you do 35 AND with 20, you will get 20 again, so you can work out the maths there. So that is why there is no change here in the accumulator. This is a very simple program. The main purpose to show you this program was to make you understand how to define the timing diagram. Now timing diagram, let me show you again. STA5060. So if I click here, you will be getting the entire timing diagram for your STA5060 for opcode fetch and memory read cycle, and memory write cycle. So that is what we have seen in the previous case. Now let us load some sample programs which is provided under this tab. Here we are already provided a ones complement of a 16-bit number. If you see the other programs, you would have noticed that many of the programs we have done in the lab, as well as some programs we have discussed in the class or in the assignments. And if some are left off, you can try understanding them by loading it and executing it so that you can understand the program flow. So let me load the simple program that is ones complement of a 16-bit number. So if you click here, the program which is already stored in this software gets loaded, and let us go through this program. First line is hash begin 0000H. The other things which you are seeing in the gray font, they are comments, so you can either comment by giving 2 slashes or using a semicolon. This begin hash begin 0000H, this hash begin is basically your assembler directive. If you try to recollect, in the class we have discussed few assembler directives like org, which is given here, then db, then define word, that is dw, and define storage, that is ds, and equ. So out of that, 2 are already being shown here, org and db. Now what does begin do? Begin sets the value of your program counter. So let me write here So what value the program counter should be initialized with, that value is stored here. Now what I can do is, let me make this as 6000H. So I'm initializing the program counter at 6000H. This means that I should also ensure that my program is stored from 6000H. Now, what is the functionality of your ORG? ORG will define from what value or what memory location will the next byte be stored. Now, if you notice here, C050 is a memory location. We want that the next two input values. So here, what is the objective of this program? Is we have to perform ones complement of a 16-bit number. So a 16-bit number is 5485. So that is why we have defined here 8554. Now the higher byte is 54H. Again, the Little Indian format will come into play. So 54 is the higher byte and 85 is the lower byte. So this is a 16-bit number for which one's complement is being done. So we are having an ORG C050. So C050 is loaded with 85, C051, which is the subsequent memory location, it is loaded with 54. Now I want my program should also start from 6000H. So what I did is I wrote begin 6000H. This is the value of your program counter. How I can ensure that my program is also stored at 6000H? I will write hash org, let me write in capital, org 6000H. After that, we are having the program. You can go through the program. I will not be discussing it. It's quite self-explanatory, and certain programs you have also done in the class. So let me just execute it and show the basic features. So if I click on the assemble, now you see here the start from this value, which is the program counter value, which has to be loaded into your program counter. This is shown here 6000, and even your program is stored from 6000 address. If you try recollecting the previous program which I have shown, it was stored from 0000 address. So this is the functionality of your ORG as well as begin. Now when I click here step by step, going to the first step, forward. So you see here the program counter value has automatically become 6003, which is pointing to the next memory location. So your program counter is appropriately initialized. So you can execute it one by one and try seeing whether the things happen as per your expectation. What is the final value we are getting? It is stored at this location. It is said that the answer is stored as C052 and C053. So here is the memory. The ones complement of a 16-bit number will be 7A and AB. So you can try working out the maths. So 5485, if you perform ones complement, you will get this. Please note that AB is the higher byte and the 7A is the lower byte. So with this, you can very well understand the other programs also. So you can try loading the other programs and explore the features of this software. Apart from this, the software can be used for showing your 8085 microprocessor trainer kit. Now this is the trainer kit which you have used in your lab also, right? The same set of features were there. Reset and 8, 9, A, B, C, D, E, F. So all those keys are here along with your registers. So A, B, C, D, E, and your execute, increment, register, next. So all those things you can try to use what you have done in your lab in this trainer kit also. Apart from this, you can also make use of this software to create a delay routine. Suppose I want to create a delay routine of 10 milliseconds. So what I can do is I can create a label, and this delay routine is used for creating a significant amount of delay between two function calls. So suppose I want my LED to be on and off after a delay of 3 milliseconds, so I can do the same here. So suppose I can write here delay subroutine label as delay for how many milliseconds? I can write here 3. And what will be the time for 1t states? So we have seen the 8085A microprocessor runs on a clock frequency of 5 megahertz. So therefore the time for 1t state is 0.2 microseconds. So 0.2 microseconds, if I want to convert into nanoseconds, so I have to use a factor of 1000. So this will give me 200 nanoseconds. So 200 nanoseconds is used. What I can make use of, how I want to use a delay subroutine. Do I want to use it with one register or with two registers or three registers? Suppose I make use of two registers. So here I can get this delay. Now it is also saying that for this format the maximum delay can be of this many milliseconds and a minimum of this. So our range fits within this range, so I am using registers B and C. If you want to use some other registers, you can use that also. So let me just click here OK. So you get a delay routine here. Okay, so this is the previous program, so let me get rid of this. So this is the delay program which you can use for your own functions. So this is what is your 8085 simulator. You can explore many other things here. Some things related to your RST instructions or your interrupts, which is highlighted here, sim and rim. They are not in your syllabus, but still if you want to explore, you're free to do it. And try exploring the feature of your timing diagram as well as your T states, understanding your machine cycles, how is the instruction size and how the memory is allocated to the different instructions. Apart from that, you can even see your devices as well as the memory elements. So we are done understanding your 8085 simulator or 8085 emulator. The similar simulators are there for your 8086 microprocessor, but they are not free as what is the software. I'll share that link for the download for your 8086 emulators. You can try it for free, and there is some restrictions in that, as well as there are certain limitations for the number of days to be used and so on. So I'll give you the links. You can download it, try to use it. If you have understood your 8085 simulator, it's working and it's functioning, the same thing can be applicable for your 8086. So with this we are done for this topic, and the revision of your syllabus covered before your midsem is also completed. That's all. Thank you.